basic requirements for this? One is AC voltage. What I am showing in the earlier, now also same. AC voltage. Followed by the transformer. Okay na? It contains the difference of half wave and full wave. I am showing diagrammatically now. And it contains the diode, similar lines of earlier. But in addition to this, one more diode is present. Like this. One more diode. Earlier only one diode. Right now 2 diodes are present. Connect these two. Now here the load is connected. It is the ground connection. It is called load, RL. In addition to this, one special arrangement is there. That is called center tapped arrangement. Like this. Because it is grounded, center tap also grounded. What's the importance of center tapping this connection is, the current is splitted. One towards diode D1, other one towards D2. Like Kirchhoff current law we are applied at the node point, you know that this is in Kirchhoff current law we observed like this. This is a node where the total current passing through this splits one direction I1, second direction I2 only because of this node. Same thing is extended here also. The transformer helps to split the current. One is towards D1, other one towards D2 with the help of this arrangement. This arrangement is called center tapped arrangement. What is the arrangement? Center tap. Center tap arrangement. Now the requirements are again, I list out here. What are the requirements? First one is transformer. Second one is what? 2 diodes. How many? 2. Third one is what? Transformer also what nature it is? Center tap. The nature is center tap. Third one is load or the load resistor. Load resistor. These are the points. Okay na? Now how this full wave rectifier should work? It is very easy to explain that using diagram. Again what you are sending now, positive waveform and negative waveform combination nothing but AC wave, AC voltage. We are always given AC voltage like this. It contains positive, negative repeated. We show the result now with the help of the 2 graphs. Both are observing with the same duration, means timings also same. It is the time. Now it is the voltage with respect to the first diode. Okay na? What is that? Voltage with respect to diode D1. Okay, see now the first case I tell you now. Whenever positive passing through this, because of this center tapping, these two are separated. Whenever the current passing through this, current is nothing but AC voltage should passing through this. For positive with this, it is positive. Now it is negative. It is positive, negative. For the waveform of this, D1 is only on. Here, D1 on. On means forward bias. Okay na? D1 is on. That because it is a forward bias. Now that current passing through the load like this. Whenever it is on, the current passing through the load resistor. Okay na? That is with respect to which one? First half cycle. This is called first half cycle. Whenever first half cycle passing through this, then it is on, the current reached the load. What if one you are observed the waveform? What is that? D1 is off. Go for the second half now, this one. During the second half. What is this? Second half means this one. At this time what happening? Due to center tapped arrangement, D2 is on. Center tapped arrangement, D2 is on. What it indicates? Forward bias. And D1 is off, means reverse bias. Okay now? That one also I try to show it now. Now another waveform. In the second case, what you have observed, negative passing through this. Negative passing through this time, D2. Now here D2. Here D1 on, it is a D2 is off. Now here again D1 is on. D1 on. Here the D2 on. Here also D2 on. Like this. We observe now, both are physically both are present, but they are not come into forward bias both at once. Because now meaning is D1 forward bias, D2 same time reverse bias. Why the reverse bias? Due to center tap. Due to center tap. Similarly, that is with respect to what waveform? Positive waveform. Means off of the waveform. Reverse this now. What is that? Negative waveform? Like this. At this negative waveform reverse the condition. What happening now? D1 reverse bias. D1, it is not visible. D1 reverse bias. D1 reverse bias. D2 forward bias. How it is possible? Because of center tapping. CT stands for center tapping. Physically both are present. But at positive time, it is only forward bias, it is reverse bias. That is a no current flow, no waveform here. Second interval, this is interval. It is on, it is forward bias, it is reverse bias. That reason, here the first part is not present. Combining these two now, at the different intervals, it is a voltage due to D2. Combining these two at the load resistor, next step. Combining those two waveforms, then the resultant current passing through the rectifier circuit will come now. Combining these two, then what waveform we are observed? The total waveform is shifted to one side, like this. It is a total time T. In terms of voltage, due to diode D1 and due to diode D2. That means one is VD2, second one is VD1. One is due to diode D1, other one due to diode D2. Here we are observed that D1 is on, now it is D2 is on. Similarly, D1 is on, D2 is on. That way the whole waveform, negative also move on the positive side. The whole waveform is appeared. There is no rectification now. Just by changing the position of the negative, that will shift it to the positive side. That one you are observed in case of full wave rectifier with the support of center tap. With this, what you are observed, the waveform count is increased. The waveform count is increased. Then the efficiency are represented 0.182 into RL divided by RF plus RL. RF plus RL. And 80 around only. Some books 80.6, some books 81.2. The different values they are given, but it should be doubled compared to the off rectifier. Okay, what value will come now? Because efficiency expressed in percentage. With that reason, the value is 81.2% is the efficiency of full wave rectifier. It is doubled than compared to the off wave rectifier. Okay, now center tapped function is what? Like this node function. How the current, total current passing through splits into two different paths or the multiple paths. Same lines, with the help of this center tap, whatever the positive or negative waveform passing through this, that should be split. One is towards positive side, towards negative side of the diode. Now, once the diode D1 is on, D2 is off, or the D2 is on, D1 is off. Another way, D1 forward bias, D2 reverse bias, or D2 forward bias, D1 reverse bias. Okay? That is the discussion for the topic of which one full wave rectifier. In the third question is very simple. The differences between these two rectifiers, because it is self-learning point. The completely those steps are theoretical steps. Okay, now off a rectifier and full wave rectifier. The short form I am showing now. One is off a rectifier. Other one is what? Full wave rectifier. It is another question. The difference between off a rectifier and full wave rectifier. Very simple. how many diodes are required? One diode or single diode. How many diodes are required now? Single diode. Here how many diodes are required? Two diodes. Two diodes. Next one now. Now here transformer is center tapped is used here, not required. No center tapping. No center tap. Here center tap required. Center tap required. Okay now? And another point now. What is an efficiency? What is an efficiency here? 0.412 RL by RF plus RL. What about the efficiency now here? 0.812 RL divided by RF plus RL. And go for the other point now. Here how much the waveform converts only off. Only one off. Only one off. It should be converted only one off. It will convert both off cycles. Both off cycles. That means positive and negative. Both it should be converted. It is only converted one off cycle, either positive or negative. Okay na? In terms of percentage, you should define now. Not necessarily this point, even though the percentage is how much? 41.2. What is the percentage is now? 81.2. That means full wave rectifier efficiency doubled than compared to the half wave rectifier, and it is a low efficiency, it is high efficiency. Okay. Next one now. These are the three main questions asked very frequently in exam. One is diode in half wave rectifier. Second one, how the diode used as a full wave rectifier. And the third one, differences between half wave rectifier and full wave rectifier. And another one, at the beginning, I covered that point. What is that? How the diode should be biased. One is in the form of forward bias, other one is in the form of reverse bias. With the last two questions now, they are the Nand gate and NOR gate, and one more is the NOT gate. Those gates, I think you are aware of that. I will cover those in a simpler way and easiest way. Now the another question, NAND gate and NOR gate truth tables. NAND gate and NOT gate truth tables. Truth tables. What is the question number now? Earlier one is 4 questions I covered. Now it's the 5th question. NAND gate and NOR gate truth tables. It is very simple. Now the NAND gate, it is a combination of two gates. One is AND gate, second one is NOT gate. Now you should show this diagram now. AND gate are represented by like this. That contains the two inputs. It is a product appeared at the outside. Product of those two inputs is this. The symbol for the NOT gate, you are aware of this. Then the output is the complement of input. What is the input here? AB, that should be complemented. Or another way to define this is, draw the AND gate first. This bubble is attached now here. This is a symbol for NAND gate. What output you got directly? Product of these two and complement. This is called the NAND gate. Now the truth table, you have to prepare the AB inputs like this. What result you got now? AB and later AB bar. Because AB inputs, A and B are the inputs. AB is the value of the output of the first gate. Then passing through this, the final output is like this. We should fill this table in an easier method. Now here the decimal values are what here now? 0, 1, 2, 3. Divide the 0 by 2. Then what will come? 0, 0. Divide the value of 1 by 2, then what will come? 0, 1. Divide the value by 2, what will come? 1, 0. Divide the value by 3 by 2, what will come? Like this. For your understanding's sake, I am showing that one also. Divide this by 2, what will come? 0 and 0. Divide the value by value 1 by 2, what will come? 0, 1. Divide the value 2 by 2, one time it will, remainder is 0. And go for the 3. Now divide the value by 2, then it will goes to the one time, remainder is 1, 1 and 1. 1 and 0 are called the binary values. 0 and 1 only the language applicable for logic gates. Okay na? 0, 0, product is 0. 0, 1, result 0. 1, 0, result 0. 1, 1, it is 1. That means AB what requirement? All input should be high. All input should be 1. Then only 1. Any one of the value is 0. Any one or more than 0. Any one or more than that. Then the result should be 0. AB bar means complement this. 0 change to 1. 0 change to 1. 0 change to 1. 1 change to 0. Complement means what? 0 to 1. 1 to 0. 0 change to 1 and 1 change to 0 is called complement or the negation. Complement or negation. This is the table is enough to represent the NAND gate. What sentence you have to write now? All the inputs are 1. Then only all the inputs are 1. Then only output is 0. Or at least one input is 1. Then output goes to 1. At least one input is 1. At least one value is high. Or at least one value is 1. Then output is 1. All inputs are 1s. Then output should be 0. That indicates the NAND gate. And go for the another gate is what? It is NOR gate. It is similar lines of NAND gate. NAND gate helps us to multiply. NOR gate describes the addition of the inputs. Now second gate is what? NOR gate. OR symbol, it is a combination of how many gates? OR gate and NOT gate. What is the symbol for the OR gate? This is the way to show the OR gate. Again you are applying the two inputs AB. Output is nothing but sum of those two. Again that will passing through the diode with inverter symbol. Then output is always complement of the input. Is OR. What way to show this now? NOR gate, this is the way. Instead of two gates, we are represented by one gate. This is called the gate. Its symbol is called gate. Now the output what it will come directly? The value of this A plus B bar. You are already observed the way how I am writing. Go for this again same pattern. But the thing is A plus B this part and A plus B bar in the last part. We observe now very simple to write the values 0 0 same table will continue 0 1 1 0 1 1 because the decimal values are what 0 1 2 3. Add this now 0 at least 1 is present it is 1 at least 1 is present it is 1 more than 1 present then also 1. Reverse this now complement it is 1 0 0 0. From this what I observed all values are 0 then output is 1. All values are 0 then output is 1. In any other case output is 0. In any other case output is 0. Close. Okay na? This is the way you describe the NOR gate. How the NOR gate differ from OR gate? If they asked how it is differ from OR gate? OR gate, what are the points? At least 1 is present, output is 1. At least 1 is present, output is 1. Now in the case of NAND gate, in the case of NOR gate, all inputs are low, then output is 1. Same thing, how the NAND gate differ from AND gate? AND gate needs all inputs are high. NAND gate needs all input are high, it is 0. That is only the case. AND gate, when it is high, all inputs are 1s. When the NAND gate is 0, all inputs are 1s. Both are complement. AND gate value is 1 at what time? All inputs are 1. Same time, NAND gate is 0. Similarly, OR gate, we observe now, all are ones, or at least one, then it is 1. Come to the NOR gate, it should be 0. NOR and OR are complement. And come to the last gate now. What is that? NOT gate. With this I close the discussion of semiconductor chapter. Very important for final exam and pre-final exam, because SAQ weightage is there. That reason you learn these 5 questions regularly and repeatedly asked questions. These are practice the answer for that. Okay na? And the last one is what now? NOT gate. Very simple one. NOT gate. NOT gate symbol already I covered earlier. Like this. It contains only one input. Output is the complement of the input. For this reason, we represent the table. It is the symbol, is the input. Output represented like this. 0 is given. Output is 1 because single input. It is output or 1. It is 0. 1 and 0. Okay. Now generally we are using as the switching purpose. We are using. It is the AC. Here I am showing the bulb like this. Here the switch we are connecting now. Switch is connected. Okay. If the switch is yes, I named as now, it is called the bulb. This is called the bulb. We have to now. S is open. S is open like this. Bulb glows. Indirectly open means 0. Glows means 1. 0 and 1 close. If it is closed, S is closed. What is its meaning? 1. Then bulb not glow. Then the bulb not glow. Okay na? Then the bulb not glow. What is the meaning of glow? Not glow. It is 0. Not glow means 0. That means it is 1, it is 0. That means the switch controls the bulb operation. Whether the bulb glows, switch is open. Bulb not glown, switch is closed. These are the points relevant to the topic. Semiconductors. I conclude now. Here the questions are. The first one is how the diode is connected. One is forward bias and reverse bias. Second one, half-wave rectifier. Only one diode is required, transformer and load resistor. Third one is full-wave rectifier. 2 diodes required, center tap transformer and load resistor. Next one is difference between half-wave and full-wave rectifier. After that, NAND gate, NOR gate and NOT gate. These are the 5 questions enough to practice thoroughly and